Hi, in this lecture, we're going to talk about our sense of taste, otherwise known as gustation. So the stimulus is going to be any water-soluble molecules and ions, and you might remember that our sense of taste is a chemoreceptor, so it's going to respond to chemicals. Now, remember, these chemicals have to dissolve in saliva first, and they have to come in contact with our receptors for taste, or gustatory receptors. Now, these receptors are on your tongue primarily. They're also on your cheeks and inside a little bit of your pharynx and larynx, but primarily on the tongue, and they're clustered into structures called taste buds. Now, there's different types of these taste buds. They're found in papillae. So a papilla or papillae is just a rounded like projection. You don't need to memorize the different types of taste papillae, but just know that these papillae are all over the tongue. You have some over the anterior, there's some on the back, and that they mainly control your taste buds. And if we look at the actual taste bud, one taste bud is a bunch of cells. So you can look at this picture down here, and there's cells here called basal cells, which are basically the stem cells. You ever like burnt your tongue and you couldn't taste for a couple days? That's because it took time to regenerate these cells. And then you have your taste cell, which is called a gustatory cell. So the taste cells have this little tiny thing called a taste hair, which you can see is a little microvilli that kind of sticks out through this little pore. So you have an opening, which is the pore, and then the taste cells have the little microvilli that stick out, and they're called taste hairs, which basically are the receptors for taste. So they don't live real long, approximately 10 days. They have a pretty low threshold, and like smell, they adapt pretty quickly. We didn't talk about a lot in smell, but our sense of smell does adapt, where if you're around a smell a long period of time, you no longer smell it, right? You kind of get used to it. This can happen if you accidentally spill cologne on yourself in the morning and you go through your day and then you don't smell it later. Taste is the same thing. So when you eat something, especially, like think of something like your favorite food, usually the first bite is the best, right? And then by like the fourth bite or fifth bite, it still tastes good, but not the same. So they do adapt really, really quickly. As we said, for a chemical to be tasted, basically it has to come in, it has to dissolve in saliva. So your little chemicals will come in, dissolve, they'll go through the taste pore, and they'll contact one of those little gustatory hairs, and then it will basically form an action potential. Now, once you get an action potential, you need to send it to the brain, and so it will travel through those afferent fibers to get up to the brain. Now, let me go to the pathway here first. So if we notice, there's 3 cranial nerves that carry our information about taste. So we have our facial nerve, which is from most of the tongue, the anterior tongue. We have the glossopharyngeal, which is kind of like the back of the tongue, the posterior third, and the vagus carries from everywhere else. So all of these axons, remember, are going up to the thalamus. It was the traffic cop for all of our senses, right, except for smell. And then that's going to route it to your primary gustatory cortex, right, your taste cortex, and the parietal lobe. So these 3 cranial nerves get it there. Now, notice so they go to the medulla first. And the reason they go there first is that's your center for swallowing or vomiting. So ideally, if the food is good, you're going to be triggered to swallow it. But if maybe it's rancid or it doesn't taste good, then you're going to be triggered to vomit. So that's why the medulla is involved. And then the parietal lobe has the taste cortex, and this is where we interpret it. And as I told you earlier, taste is about 90% smell. So, if you have to, eat your Brussels sprouts or eat something or take some medicine that you don't like, or you're trying to get your kids to do it, just have them hold their nose and you won't be able to taste it as well. And you can do it. Fun trick, get a potato and an apple and peel them and cut a small piece of each, make them equal size, have a willing volunteer close their eyes, open their mouth, and you can put the potato in and have them chew it up, and you could try it with the apple, but have them hold their nose. And if they hold their nose, it's really hard to tell the difference between the potato and the apple until they let go of their nose and they're allowed to use their sense of smell. And if you want to be really mean, you can try it with an onion. So if we look at taste, just know that there's basically 5 main types of taste out there. There's sweet, sour, salty, bitter, something called umami, and then I added water because some people say you could actually taste water. So when we're looking at sweet, sweet is going to be mainly sugars that are going to cause that sensation. So we know that it's not necessarily that you have a map of your tongue and that sweet is only on the tip, etc. We do know that certain areas of the tongue seem to be a little more sensitive to the different tastes, but that varies by individual. Sour is triggered by acids. And, you know, and a lot of people, their sides of their tongue are a little more sensitive to things that are sour. Salt is metals. Your salts, sodium chloride, NaCl is table salt. Bitter are a lot of alkaloids which come from plants, but they can cause a sensation of bitter. And then umami is kind of a different thing. They say it's like a Parmesan cheese or a broth type. It comes from glutamate, which we talked about previously. And so you can see some of your foods that might give you this kind of like savory type. And then they say that we have water receptors. Some people say they can taste water. As far as I don't know if you can actually taste different waters and get an idea if they taste differently or not. It might be something fun to try. And we also know that as far as our sensitivity for taste, that just like everything else, as we get older, we lose our sense of taste. After around 50, it starts to decline. We have less saliva. And then, you know, as we lose our sense of smell, then that also causes issues. So if you work in like geriatric populations, you might notice that they might try to oversalt their food because they don't taste it as well. And then you have to be careful because you're trying to get, you know, nutrition and eat properly. So that's a problem. And, you know, I always say, imagine if all your food kind of tasted like bland oatmeal. You probably wouldn't be motivated to eat well either. So just keep that in mind if you work with that particular population. And that's our overview and our lecture on gustation.